Hey there, welcome to a phenomenal episode of the Into the Impossible podcast featuring my friend and Nobel Laureate, Katalin Karikó. Katalin won the 2023 Nobel Prize in Medicine or Physiology for her research and collaboration in the invention of the COVID-19 vaccination. Now, I know these are controversial, and indeed we did speak about the controversy, but Katalin is a fierce, unstoppable force. I just love talking to her. And I know you will too. Her insights are infectious, no pun intended. I want you to dive deep into this episode and really take away the human spirit can never be defeated. When you have such incredible intellects like Katalin, there's no telling where the human mind can take you.
Professor, nice to meet you in person. Thank you so much for coming on the Into the Impossible podcast.
Thank you for inviting me.
It's a great thrill to have you here. I want to start off with a question. Maybe you know about this, but maybe you don't. In Hungarian, allegedly, there's a term, a phrase, which refers to Hungarian people, and it's the Marslahok. Have you heard of this phrase?
Yes.
Can you explain it for the audience that might not know what it means?
So there were famous Hungarians, and then they were at about the same age, and they were very advanced in physics and mathematics and so on, and they kind of named them, coming from the Mars.
Right. Allegedly, Leo Szilard, who lived here in La Jolla for some of his life, I think towards the end of his life, he was asked once why aliens, if they're so numerous, as many people believe, and we're going to talk about that, he said, it was asked, where are they, along the lines of Enrico Fermi, and he said, they're here, they're called Hungarians. And I find Hungarian, the language, the people, the culture, so fascinating. You brought with you some books for us to read. This one is the Hungarian version. And so I thought what we do is start off, you can start with the English or the Hungarian one. It's been translated into how many languages now?
11.
Over 10. And this one, I like to do the following. I like you to describe the title of the book, the subtitle of the book, and the cover illustrations and the cover artwork. We call this judging books by their covers.
Yes. So this is the title is Breaking Through. That is the English title, and it is my life in science. And this book I wrote during the COVID and during the development of vaccine, and I did not want to write this. I thought that who cares about the boring life of a scientist? But so many people approached, and finally, I decided that I have to do it, and I got help, and then the book became. And so on the cover is my family. Here in the front up there is with my daughter, who is a 2 times Olympic champion.
Yes.
And my parents is the next picture, and there is me. And then when I was just a student, elementary school student, and we went to biking different places, and finally my husband, me, and my daughter is here.
And on the cover is also a DNA strand on that cover, but it really should be RNA, correct?
Yeah, but the RNA is made from the DNA, and people would not recognize as easily.
A single strand. So one of the connections between your work and your description as a scientist, what I love about this book is it's such an honest portrayal of what life's like. Typically, especially with Nobel Prize winners that I've encountered, we get the impression that everything came to them in a flash of insight. It took, minutes or seconds, and they came up with it. And of course, nobody else can relate to that, because how can you relate? But this book is so heartfelt and humbling and beautiful. It was really delight. I listened to it, so I have the audiobook version of it, so you can't sign that, but I did leave a review on Amazon, the most important thing you can do. But it's a remarkable book. I haven't read books that are this raw, this honest, this truly accurately portraying the life of a scientist. But before we get into those details of this wonderful book, I want to go back to Szilard and Fermi and all the others. But first, before we talk about life in the universe, I want to ask you the question that fellow Nobel laureate Erwin Schrödinger asked. He said, what is life? So can you define for me and my audience, what do you consider to be alive?
Yeah, that's a hard question, actually, because Albert Szent-Györgyi, who's, were teaching in my alma mater when he got the Nobel Prize, he said that as you look at the closer and closer to the molecule, and you lose where life is really, because, when you go to the, you are studying going out the universe. Here is when you go down deeper to look at the molecules and others. Somehow life get lost. Where is life? So it is difficult for me to define.
Do you think it's important that we have an acceptable definition of life to actually do research in what you do and what other people do, extra planetary biology, for example, with people here in this building that you met recently? They're looking for life throughout the universe. Do you think it's important, or is it a challenge that we don't have a universal, quote unquote, definition of life?
I don't know that. I don't know whether it is important. I don't know. I don't even believe that there is life outside this world. I don't believe.
Why is that? Why don't you believe? Is it because we don't have evidence?
So many accidental things happened here on Earth, and so I don't believe that it accidentally somewhere in the whole universe could happen. I don't know.
So that kind of preempts my next question: is, do you believe that there's life elsewhere in the universe? And I've had many people in this room and on the podcast, including fellow laureates Jack Szostak and Thomas Cech recently, and everybody's interested in this question. And everyone seems to, kind of agree on some things, but very hotly debate other things. And the question I always have is, would it change? Would it change your life? Would it change your philosophy, your spirituality, if I can even mention that? If tomorrow we found out that there was some mold discovered on a planet around Proxima Centauri B, or actually if it was discovered on asteroid Karikó, which you have, so you have a Nobel Prize, which you brought with you. This is my chocolate version, but you actually have an asteroid, and your daughter has 2 gold medals. So I won't ask you which of these incredible, talas, representative symbols that is your favorite, but what would it mean if humanity tomorrow discovers life somewhere else in the universe?
I don't know. I don't really think about these hypothetical things. I usually like to look at data and make a decision if I have some knowledge on the field. But otherwise, in these days, I get so many people sending me their hypotheses, ideas, and I just had to tell them that maybe it's a great idea, but I'm not an expert and I don't have time to study it, whether I would make a judgment that whether it is a good idea or a bad idea.
I think it's the second most interesting thing that you could study, other than studying the origin of the universe, which I get paid to do. One incredible thing about this book is that it describes what it feels like to be a scientist. Again, not just the ups, not just the highs, the prizes. You've won so many, and I'm sure it's overwhelming to you. In a very long and illustrious career that kind of you became an overnight success, so to speak, but you really worked on this for decades. Talk about what kept you going. What was the motivation that kept you, so steadfast? And then I want to talk about how you did it, the tools, the approach, the frameworks that you use for my audience. Many of them are scientists, young scientists, men and women that listen to this podcast.
I was excited about the science itself and the possibility. And of course, as all scientists, what I'm doing, I don't know whether it is doable, but kind of the scientist believes that, okay, maybe try this and that and 100 different things, and maybe none of them work, but, they still have this idea. And that's what, I focused always on science and not the prestige, not the promotion, because none of them came on my way. So I focus always on science and get excited. And when people judge me that, I am unsuccessful, I'm successful because technically, a lot of technical problems had to be solved in the lab, when isolating things and purifying the RNA, and many, many other tiny things, which was, critical to improve the RNA performance.
In the book, you start off with the story of your life. It's an autobiography as well, our memoir, really. And you talk about your life as a butcher's daughter in a house with no indoor plumbing. Those circumstances wouldn't necessarily seem likely for someone to go on to not just win a Nobel Prize, but to do the research day in and day out. Your father was a butcher, right? He wasn't a professor. He wasn't an engineer or scientist. And this is in communist Hungary before the fall of the Iron Curtain. Those challenges are punctuated throughout here with moments of idealistic beauty when you talk about going and getting chickens and milking animals and then, probably giving them to your dad, because he would appreciate it. Is there anything in your childhood that, specifically made you attuned to the world of science, that you would be a scientist and contribute to this tapestry that we call the scientific process?
I think that all kids are interested in science, what is around us. And then, that although we didn't have many things there, but I didn't know our neighbors, television set in the neighborhood. So we just played outside and helped with the animals to feeding them and watching them. And so it was also in school, so that when we went to schools, that the teacher took us outside, we went to a garden, and he just picked up things and just asked a question, isn't that interesting, this fall, and why the leaves are coming down, and why this leaves this kind of this, and this is other kind, and other color, and so it was just, wondering, asking questions, and then, the kids answer something, or not, and just wonder about and were curious. And that's what somehow, this curiosity, what we need to keep in the children.
Yeah, I always say that scientists are like children. We are curious, we're imaginative, we're creative, but we're also like children. We fight with others, we're jealous, we want our toys just for ourselves. And it's kind of interesting that you also have this wonderful book written about you by Debbie Daddy, which is an interesting name, illustrated by Juliana Oakley. And it's about you, Katalin Karikó, and the race for the future of vaccines. Again, with a DNA. I don't know why. RNA is supposedly, and I want to talk to you about RNA a lot, because I've come to love RNA more than I love DNA. But this incredible children's book has this catchphrase of yours, which comes from the book. Mm-hmm. You say it for the narrator, who sounds very much like you, which I was very impressed with. She says at the end, if I could say 3 words, don't give up. And this book called Never Give Up. What does that mean? What should I take away from that? Or what should a scientist, or even not a scientist, just an ordinary person who struggles, what does that mean? Never give up.
So that, everybody has a dream, and then and they give up because, the circumstances, because, I happen that things are not working out as expected. Or, when we have in a childbearing age, the woman is the one who will carry, but eventually raising the child should be the family and extended family, and so that I encourage always that rely on them, ask for help, and then when you don't overdote your child, that let them learn to how to stand up for themselves, and so everything is just don't lower the bar just because you think that you are less. So just you have to value yourself and don't give up.
It's truly an amazing story of perseverance, not just from these humble origins. And I don't think people can really appreciate how challenging it was. We just take for granted Hungary's a friend of the West and then very much westernized in many ways. But back then it was a dark place. And I mean, I should tell you, I told you, I think by email, my grandfather was from Ungvar, Hungary. So I'm familiar with the culture as well. And he was very proud of that. I think Hungary is a very special place, not the least of which because it has this unusual language that's closer to Finnish, I'm told, or the language of Finland. I don't know how that happened, but maybe that's a story for a third book. But the early life and then living under the specter of communism and the secret police. I can hardly, get away from the specter of my tenure review committee or my promotion. I mean, how did you possibly handle that pressure as a young student, and possibly the fact that they were threatening you, threatening your father, threatening your family, and could have really just destroyed your career in a millisecond and your life?
By the time I was, had this situation was not as serious as our parents. My parents were telling me that, there were just a big car came and they took somebody and nobody ever seen them again. So that was at the beginning, in the 50s, it was, execution and things like that. But,
horrific.
In my time, it was not like that. It was, yes, they still could make your life difficult, but it was no execution, and so it was not as serious. It was difficult because we were under embargo from the West, so we couldn't buy certain equipment and other things. We had to be creative and create chemicals and other things we have to do ourselves because it was, under embargo.
Talk about that, and I've brought with me not a cow brain, but a human brain, which plays a role in this in your story. So take the human brain. It's plastic. Don't worry. Tell the story of the role that a cow brain played in perhaps a solution to a problem that gripped the world and that is flowing through people's bodies as we speak. How did this influence or impact your career? This brain situation in terms of the creativity you and your colleagues had to.
Yes, I have to say, the genetics was the most important when I was at the university, and I want to study that, but the only opening was in the lipid team. Mm-hmm. And I thought that I would spend the summer to investigating in the laboratory, and the professor said that go to this Fisher Institute and collect, some water fleas. You are dreaming about big, and finally you are collecting these water fleas to make an experiment. And when I went back in the fall, a team came, approached us to, they need a certain phospholipid, negatively charged phospholipid to make liposome. And it was in the 70s. It was just published that kind of liposome can be used to deliver, actually, they did DNA, RNA. But we did try to make DNA to deliver. But, this phospholipid fraction in the Forsch reaction was available for a couple of Deutschmark at that time. But we were under embargo, so we had to go back, Judith Forsch paper from the 1940s something, and then check out that how to get these phospholipids. And it was that how to isolate from cow brain. And then the PI went to the slaughterhouse, came back with the cow brain. And then, it was good that my father was butcher and I was not gooish that, oh my God, there's a brain. But, we started to isolate, precipitate with acetone the proteins and all of these different fraction of chloroform, ether, all of this organic solvent. Again, there is no hood. We just open the windows and we work there and we get this reaction, fraction. And then we did a delivery of DNA with these liposomes. And so that's how it started. And one day, just, walk in this guy from the RNA unit, and he said that I can make my PhD there. And I said, okay. So I am not a visionary. So everything happened by just chance. And that's how, after making liposome, I started to work on RNA.
Yeah, and let's turn to RNA now. Doesn't get the coverage on the cover of books, literally, even your book, but it's called by many people, and Tom Cech's new book is called The Catalyst. Describe, please, what RNA is and perhaps what mRNA. I always get tongue-tied with mRNA. It's hard for me to say, but I said it that time. Describe what specifically is so important about messenger or mRNA, please.
So all of our chromosome, it is in the nucleus and it is in the form of DNA, and they are very stable. You know that even from dinosaur, we can have DNA out. But it is in the nuclei, and then, the translation occurring in the cytoplasm. And the scientists in the 50s were trying to understand how the translation is happening. The protein is made based on information, but something has to carry the information out where the protein synthesis factory. Mm-hmm. And then, they were looking for this X molecule, which was very elusive because it was so labile. And they, couldn't identify until 1961 when they discovered that there is a messenger RNA which goes for the proteins, and it just carries all of this information and quickly degrades.
It's very unstable, right?
Yes.
But it has other properties like autocatalysis, or it can act as a catalyst. Why is catalysis so important? Why is, and ribozymes, and why is that so important for replication of life?
Yeah, actually, even the protein synthesis factory, the ribosomal RNA is as an enzyme, is working in that process, linking one amino acid to the other. So it is why it is important, because they say that the RNA was the first molecule, and then it can replicate. And even early on, in 1955, 56, they already discovered that when tobacco mosaic viral RNA was phenol extracted, so the pure pure RNA was put in the tobacco leaves, brushed in, and there were virus was coming out. And they realized that you don't need those proteins there. Actually, the RNA carries all of the information to create a virus. That was the major things they realized.
Is it I mean, I was reading your book, listening to your book, and then, really the only difference, not the only difference, it's a single strand versus double helix, but there are two letters that are different, uracil, is that how you pronounce it, and then thymine, right?
Yeah.
So is it possible that DNA is basically just made from two RNAs and then somehow in a nuclear fusion or some magic happens and the U gets twisted into a T or two U?
No, there are, the desoxyribose is a big difference because this extra hydroxyl on the ribose is why it is so labile.
So labile means what specifically?
On the ribose, the hydroxyl group is there, and then it can be, you don't need even enzyme to degrade because it can, with the phosphate ribose backbone can be just terminated. So that's why it is very labile. So this ribose versus the desoxyribose is the major difference.
And you talk in the book a lot about the fascinating nature of chemistry to you is this nature of locks and keys. And of course, that becomes a metaphor for your career, working with wonderful colleagues and then some not so wonderful colleagues. I want to talk about that too. But talk about the relationship that you perceive with your co-laureate, Drew Weissman. Talk about that. What aspect over a copy machine and had this wonderful story of how you guys got together maybe wouldn't have happened in an age of, the digital age. Maybe such interactions don't happen. We'll talk about that. But talk about the specific innovation that you and Drew had worked so hard on and what was the key to sort of unlock that particular lock-key relationship.
I was working at University of Pennsylvania in cardiology with Elliot Barnett, and then we tried to invent new things. Later in neurosurgery with David Langer, again, we try to use, the innovation could come, that one scientist is understand one part and there is a physician who has a medical problem and they educate each other, respect each other, and they can come up with the new things. And that happened with Drew Weissman as well. Luckily, in 1997, when we met, I was, we couldn't get digitally the publication yet. And so we used the Xerox machine. And so that Drew was interested to have a vaccine against, HIV, a prophylactic or a therapeutic vaccine. And I was, like to brag about that. I can make RNA and I am working with RNA, but all of this messenger RNA I worked, it was coding for therapeutic protein. That's what I tried to, use for...
Tried to create an AIDS vaccine early on.
I myself, was therapeutic proteins such as, for stroke treatment or heart failure or something. But Drew was interested in, making vaccines. And so that's what, we start to educate each other. I told more about the RNA and made the RNA, and I learned all of the immunology from Drew because it turned out that what I learned in the university, it was already all outdated information.
On the immunology side, but obviously it prepared you very well for the work that you'd eventually do with RNA and so forth. In the book, you described, in the phrase that kind of surprised me, you described viruses as geniuses. What does that mean? What did you mean by virus as genius?
In my PhD thesis, I screened for antiviral effect of 2', 5' oligonucleotides, so short molecules. And then I was reading David Baltimore's book on viruses, and it turned out that they are so smart. They always figure out how to get around the immune system. And I was just amazed at how genius is that. Of course, they don't have the brain, but, the evolution, and they can replicate, and then different mutation can be introduced and can be, beneficial for the survival of the virus. And that's what, I was just so amazed. And the immune system, there is a fight constantly there, and the immune system is figuring out something, and the virus is hiding somehow. Yeah.
There's a saying I've heard that, when the student is ready, they meet their teacher. More or less when the situation presents itself, the prepared person is ready for it. What about your work with RNA and messenger RNA was so valuable in the COVID vaccine preparation? You really did most of the work that was involved with that decades earlier, correct? I mean, the COVID vaccine is using messenger RNA as a platform. So maybe you can describe that. What is a platform? What does that mean? And what sorts of ancillary other tools were necessary, lipids and delivery mechanisms? What can you say about the technical? And you could be very technical here. My audience is very, very wise.
The messenger RNA, actually in the early 90s, scientists started to use maybe as a therapeutic or vaccines. I mean, papers out from 92 from Floyd Bloom was, treating animals with vasopressin mRNA in the brain. And then some in 93 already used as influenza vaccine, the messenger RNA. And you can see that more paper came out maybe once a year, not very frequently, but, using for cancer vaccines. So there were people thinking about it, but as I recently learned, most of them, they didn't get funding and they left the field. And so I was working with mRNA almost 10 years before meeting Drew Weissman. So what was critical, that when Drew could make a very special cell type, which is called dendritic cells. And he generated human dendritic cells. And when we used this messenger RNA, which I made, it turned out that it was so inflammatory. Why it would be? In our cells, we have mRNA. Why it would be inflammatory? And, the idea came, of course, because the RNA is outside, not inside. And could it be that it activates some alarm signals? So what we did, we asked the question, is all of the RNA is such? And because I already worked 10 years prior meeting Drew on RNA, and I had a repertoire of different isolates, so that we did an experiment where we used these human dendritic cells and put the different type of RNA isolates on it. And that's what we discovered, that tRNA, the transfer RNA, which contains, 25% of the nucleotide, as is modified. It was not inflammatory. So that gave us the idea. So it was an, curiosity-driven science, and it gave us the idea of maybe modification maybe would make it, the RNA, non-inflammatory. But how you can make it?
Right. And so the replication of it, and especially, the project that BioNTech and Pfizer and Moderna and others came to produce was under the auspices of something called warp speed. But that always gave the notion that the scientists started from scratch, but in reality, what was the biggest challenge? Let me ask you, what was the biggest challenge for developing the vaccine to actually? Was it the distribution? Was it the physical production of it? What do you view as the most complicated technical problem that was solved during the COVID-19 vaccine programs?
Yeah. So as you know, we just created and providing that modification is important. And so what happened is during the COVID was the scaling up. So when I went to the BioNTech, for example, from 2013 from UPenn, one thing was that what I did at the bench, it was not scalable, so that we had to, the purification and the other things, had to be scalable. But that was, still the scale was still very small. But now that you have to make kilograms of RNA, tons of lipids and so on, and then you have to figure out how to scale it up. And that was, a challenge, scaling up.
Scaling it up, that was a huge challenge. Another challenge was the public perception of the vaccine. And then, in fact, you talk in the book about the challenges that people have to, the safety of it, the efficacy of it. It was prepared too fast. It changes your DNA and so forth. What of the, challenges to the COVID-19 vaccine specifically do you feel are most legitimate, that are you speak about menstrual cycles being affected? Are there still any other lingering concerns that you feel should be investigated or looked into more, or are you more comfortable than ever with the actual COVID-19 vaccine?
I have to say, when many of the vaccines were live pathogen, they are replicating in the body.
Yeah.
And there are DNA, there are RNA, and the people never thought about, it can incorporate, because the viruses cannot incorporate. So you deliver an RNA, it needs so many tricks to get into the genome. That's the HIV,
right.
From the RNA you could incorporate. But they need all of those tricks, all of those enzymes, and you don't have in this RNA. And but I understood that the public, they don't know many things. like you mentioned the menstruation cycle disturbance. More than 100 years ago, when the diphtheria vaccine was introduced, it was already a publication out, which the title says that. So all of the vaccine is doing this, but the people were not aware of that it is not special about the mRNA vaccine. It is all the vaccine, because all of the vaccine has an adjuvant, which alert the immune system that you have to pay attention, this load, you have to pay attention. And that stimulant cause things. And that's, that's normalizing after that. And many of and this first paper, actually, this 100 years old paper, describes also that the people never grateful that they didn't get the infection, but rather anything what happened after the vaccination, and it's happened to them, they blame on the vaccine.
Interesting. Yeah, I remember some story. Maybe it's about Ben Franklin. It might have been about one of his children who died because he wasn't exposed. Or they had some primitive, or they're not vaccinations, but they would expose to people that had smallpox or some articles of clothing. And I guess he didn't do it for one of his children, and he kind of regretted it for the rest of his life. I'm vaguely remembering some story, but you know more about this than anybody, especially with Ben Franklin involved. You talked about kind of the challenges you faced as a student. But I'm more interested right now for my audience. Again, you're the 21st Nobel Prize winner to come out. Many of them listen to the podcast and have sat in that chair. And the question I have is to distill down what you do. And as I see it, one of your superpowers, you have many of them in terms of resiliency, just you're indefatigable. You just cannot be. I would not want to go up against you or your daughter or your husband or any way, shape, or form. But one of your just incredible superpowers is your ability to read and consume and distill scientific publications. Talk about that, because maybe you don't know, but there's a lot of distrust about this peer review process and kind of, maybe not in scientific circles, but maybe in quasi-scientific circles, people that are really criticizing peer review and even saying that some of these journals, are predatory and so forth. Talk about your techniques. How do you, if I hand you a paper, something in your field, obviously I'm not going to, you've read 9,000 plus papers. Actually, you read 9,000 when this was written. You probably read another 9,000 since it was written, because it seems to be not only what you do, but what you love to do. So how do you read a paper? And you can be as technical as you want for my audience. Many of them are graduate students, postdocs, and et cetera.
So, at the beginning, I purchased Science in Nature. So why I get from the mailbox I already was reading about, and I was get so excited. And many times, that I read A to Z, so I read through, and then the techniques, and I said, oh, maybe this is an explanation for some phenomenon I found in the lab, and I can do that. And next day I went, because I had no grant, so I no technician. I have to do myself everything, and so I could do it. And so this, I have to say that I learned that when I was reading into the papers and I find typos, I already stopped. I think that the person is not paying attention to that detail. And also when I find something which is outdated information, I immediately stop reading, no more, because that's already, when they say that single-stranded RNA with triphosphate can activate RIGI, which was published in 2006, but later it was not true. So I stopped, because then spreading information which is outdated, and I don't read anymore. And then when something is exciting, even the details of the techniques I read, because at age of 58, I still did I did all of the experiments with my own hands, so that I said, I can do it. And so it is, this is how I,
Do you use any kind of tools, any artificial intelligence or citation analysis software? Do you, any?
No, mostly in, NI, natural intelligence, just my brain use that. But I have to say that, like, for example, I had these tables in Excel tables, and, each paper maybe in one line there, and what did they delivered, or what was the method, and also an abstract of the paper. So when I was writing a review, then I could just go to these tables, and I did tables for everything. When I had to write, for example, grants, then I had also a paper for stroke, for any disease, like I submitted for cystic fibrosis, when the disease was discovered, when, gene was discovered, which kind of clinical trial, what did they try to do, and why it failed, so that I had this collection of information in one place, and that's why I went and refreshed my memory. I usually at colleagues, I never said that how much I love to write grants. It is crazy because I never get an R01 in my life, but, focusing on like couple of months and reading everything about that, what they did, how did they try it, and then I come up with a new idea. Wow. And it was just, and then write it down, and and I get back that it's not good enough or something. But
my favorite is when it's very good, excellent, very awesome, and then it's rejected. It's like, what do I have to do? You obviously just have this supernatural, as I say, these abilities, but you also have this incredible work ethic. And one thing, I really keyed in on in the book is that you were never intimidated. You never were intimidated. I guess if you can face down a secret policeman coming to your door and threatening you and your father, then, asking a question of a colloquium speaker, no matter how famous she or he is, it never intimidated you. Give some advice to students. When they go to lectures, when they go to talk, many of them have what's called the imposter syndrome. They're scared. They don't think they're good enough. Are there ways that you can approach that?
They have to believe in themselves. And they do not have to compare themselves to others. And because that's what happens, they look at, and they also realize maybe that the others, not that good, and they are advancing, and I work harder. If they pay attention to that, they are not paying attention what they can change. Because that was my mantra, which I learned in high school from János Seje book, that how to handle stress. And I have to focus always what I can change, what I can do, what I can influence, what I can study. And do not pay attention what, I cannot change. If I am in the lab, I already in a super place in life, And that's what actually when several times I was terminated, or demoted at Penn, I said, the bench is here. I am in the United States of America. Where else, if not here, I can do? I just have to come up with the best experiment because I have to perform.
It's amazing to think about how close you came. And I do want to talk about that in the context of what we scientists call the multiverse and all the different garden of forking paths that could have happened but didn't happen. But before we get there, you mentioned, when you were, you did get fired, or you didn't get fired. You actually accepted a job at another university while you're working at Temple. You got a job at Johns Hopkins.
They
offered you a position. And then your postdoc advisor, Robert Suhadolnik, is that Suhadolnik? He had been responsible for your immigration to America from Hungary with your daughter and your husband. And you did work with him, but eventually you got a better offer and you were interested. And you're right. It's a free country, we say about America, but he was not very happy with that. Can you talk about that? Because people don't really understand how difficult the life of a postdoc is. I actually think that there are too many postdocs, because postdocs kind of give you the impression you're going to become a professor. And while it's very difficult to become a postdoc and you have to be very good, it's exponentially less probable, even if you are good. We had 400 applications for one job last year in this department alone, which is, a great department, but still, it's unbelievably challenging. Talk about that as a setback that actually led. I mean, you might not be here, you might not have done the things you've done for the world and for yourself and your family. Talk about that event and how you overcame it, because you do say things that I could never do. And you said this to Greg Zuckerman, our good friend that introduced us. You said, I always emphasize the positive, and you never held a grudge. How is that physically possible, Kati? I can't. I wanted to punch the guy in the face when I heard about it. And then later he has the chutzpah to come to one of your talks. And anyway, please talk about that event, but in a way that someone who's been faced with either quitting, being fired, maybe deportation. I mean, how did you handle that, Kati?
I hardly can see any person who is just negative. There is, Professor Suhadolnik invited me to this country. I learned so much from in his laboratory. He loved me. He liked all of the research we were doing. We published one issue of biochemistry. We had 3 papers, just one issue. And in 3 years, I was working day and night. And we'd run clinical trial for HIV patient, double-stranded RNA we delivered. We published in Lancet in 3 years. And then, I wanted to do molecular biology. And obviously, he didn't know, because when we received the protein, he said, change the amino acid. I said, we cannot do on the protein. And I wanted to go to Johns Hopkins. And he wanted me to stay. And that's why he tried to threaten me that, he invited me. So if I want to leave somewhere, then he deports me. And I didn't believe, but he was so screaming, and I cannot go back anymore in the lab. And so he really reported me to deportation, and I had to show up and pay the lawyer. My salary was $17,000 a year, and I had to pay a lawyer from that in 1988. And he called up the Johns Hopkins, and they withdrew the offer. That they said, you have some problem there so that's what again, you are there and you face with something, and I have to come out from this. And then I thought about who are those who hated him, and call up one of them and said, I need help. I will not get the recommendation letter. I need a job right now. Later, when I went back, and I was already at the University of Pennsylvania at that point, and he was there in the audience, and I started my talk to thank him. I told that he invited me to this country, and I learned so much. He wrote a book on modified nucleosides, the textbook, and I learned so much, and I was very thankful. And then at the end of it, he came and he said that he was proud of me, and he hugged me, and I was the only one remember. And then I said, okay, for the future also, let's forget it. Don't remember any what is negative. Because, if you have a grudge against somebody, it will poison you. The other person won't even remember. I believe that he did not remember. And many other people, who treated me badly, they don't remember that part. They just remember that they have. And why? Okay, I will remember that too. And I am grateful for that. And if not firing me this way, I wouldn't be here today.
Hey there. I just want to make sure that you help this channel turn viral and help me support the podcast by subscribing. Only about half of you watching or listening are actually subscribed. So I really want you to give me a helping hand, inject me with that confidence, and boost my overall ability to bring you great guests like Katalin and others. Got amazing guests coming up on the podcast like Max Tegmark, Jan LeCun, and many, many more. So do me a favor, subscribe or follow wherever you're listening to or watching this conversation. And now back to the episode. Yeah, that's wonderful. Actually, I was I had a similar story, although it has not led to the kind of breakthroughs that you describe in your book in your life. But I too was fired as a postdoc, and but thankfully my advisor, she was able to convince my future postdoc advisor, Professor Andrew Lang. He was the husband of Frances Arnold at Caltech, who I'm sure you know. And then I moved down to Caltech from Stanford after getting fired. I thought it was the worst thing that ever could happen to. I'd never been fired from any job. Got fired from this prestigious university. Ended up at another university that's very prestigious. And because of actually David Baltimore, who you mentioned, he was the president of Caltech, and he allowed myself and Andrew Lang to write the first grant proposal for a telescope that we later take to Antarctica. And it was rumored to win a Nobel Prize for a brief moment in 2014. But this is kind of where the similarities end, obviously, between the two. My book's called Losing the Nobel Prize, Not Winning It. As I say, I couldn't even fathom, kind of the magnanimity of your spirit, just the way that you can do things like that. And then later on to find, after you've done so much tremendous work and just these bean counters at the university you describe at UPenn, who knows your work and the quality of it. He's an eminent scientist himself, but all they care about is this number, dollars per square foot. And one day you come into the lab in 2013 and you find all of your precious chemicals, your bench, and that's all you had. It really is. It's like taking away, a millstone from a miller or a butcher's knives from a butcher, right? That's all you had. And they took it away from you. What was that moment like? I mean, how? I just can't say enough how impressive a human being you are. But to go through that, somebody's going through that right now, in the unlikely instance that you're listening to this out there, but maybe there are people. That's really kind of, it seemed to be the end of the road. And yet at some level, it then impelled you to go in a different direction that you find yourself in. So what was that that event like, and how did you overcome that? Where it was kind of fighting against this faceless, purely venal, focused on money only situation, as many universities are.
I have to say that in December 2012, I already knew that they would kick me out because, I couldn't get the grant. And that was the last blow. And, but in 2013, in March, Moderna, who was based on, modified RNA, they received $240 million from AstraZeneca. And I thought that things are changing. And so I hoped that, I also received from Takeda $800,000. And I was just coming from Japan, actually. There's a little red carpet treatment I got there, and I was surprised to find my stuff on the hallway, and somebody was cleaning my bench there. And so that's was shocking, but, not 100% because I kind of learned already in December. And so I have nothing against Sean Grady. I understand that he's a neurosurgeon. He experts on operating brain, and then, he just can see that whatever I am doing is not appreciated by experts who are at the NIH. And I don't angry even with them who at the NIH said no, because I can imagine that how many things they have to do, right? This, leading the lab. And so I read through those who, evaluated my last grant. I don't know anybody, and I don't know who they are, but, they put me down quite, quality-wise also. Only the university was number one. Me, not. But, that's because what was in the grant and the abstract was very remote from what they were doing. And, they did not could understand so quickly that, okay, what is all about using RNA for stroke treatment.
Even though, yes, it would later come back to award you with many honors at UPenn as well. So you have said, don't focus on what you cannot change. Because you're fired, don't start to feel sorry for yourself. You just have to focus on what's next, because that's what you can change. So it's sort of this wonderful notion that, the past is unchangeable, it's fixed. The future is completely in our control. And what we have is the moment that we find ourselves in. And taking advantage of that, I think, is very fitting, this title, Never Give Up. And then after that, I think, things just kept accumulating. People became so, just it was impossible to ignore what you were going to be what you were capable of, what you had done. And so I want to sort of talk about that. You talk at the end of the book about how many things, could have turned out differently for you. Mm-hmm. And just like we said, if you weren't, maybe if that didn't happen at Temple, or if this didn't happen at UPenn or any other institution, maybe you wouldn't be here, or maybe I wouldn't be, But then you say that kind of is upsetting, because maybe it means we're missing some other Kati or Brian or something, and there could be some other person that we are missing out on. So I want to ask you, what is academia doing wrong? You were an adjunct research professor. You weren't on the tenure track stream. First of all, was that ever an issue if you could have been just a research faculty and kept doing that, would that have been okay for you? And then second, how can we better serve we have many research faculty here and that I collaborate with. How can we better improve their lives so that they can do discovery so that they're not missed out upon?
I was not even adjunct faculty. I was senior research investigator. I was demoted in 95. So every time I wrote a grant, Sean Grady had to write a letter that if I get the grant, they will give me space. So it was like already some red flag. Yes. So, I was thinking about what is wrong with the system, and others, much sophisticated people already thinking. Again, coming back what Shaya said, you or the Stoic, Montessori,
really,
and others that focus on what you can change. And I believe that the people can change themselves, the people. So that my story is about that how you survive, how to handle stress, and how to stay healthy. And then different situation when, something even when the patent was in question, that whether they should file a patent or not, you just come up with something, and Fujimon had no hair, and I said maybe it is good for hair growth, and then that is the thing, that you have to survive the system, and always the science was important. What is the problem in present academia is that somehow is the prestige, the promotion, this is the goal. And then now that publication and research sometimes is just a tool to get there. Mm-hmm. And if I would care about, that prestige and other thing, I would leave the mRNA just like all of the other people who in these days, they say that, I started, but you left.
Right, exactly. The perseverance and the resilience to stay, because all scientists are going to face hardship.
Yes.
There's no such thing as someone who gets through and gets to this level. But, I'm curious, I call it the Hunger Games of academia, because science is, it's an infinite game. You can't win science. There's no, you won a Nobel Prize, but that's not the end of science. You're still, I would bet you're still maybe even more active in science and more just energized to do stuff, because now you at least know that you were right and that you did something that did change the world, as Gregory Zuckerman's book says, it's a shot to say you took the shot that saved the world. So my question for you is, for other people that are struggling and, in these kind of purgatory, no man, no woman's land of academia, between postdoc and faculty, the average age for an R01, in the medical field is over 40 years old. I'm more familiar with physical sciences, but that's pretty old, when most people have kids by then, and, men and women, and especially women, how challenging it is to give birth and then raise a kid and so forth, and then be writing a grant, which has a 3% chance of success on that. So somebody that's dealing with that situation, that doesn't have the protection of tenure, what would you say they should use as a rubric, as a criterion to know maybe when not to give up, but maybe sometimes realistically they might have to pivot to something different? Is there a way that that it's maybe it is time to move on, not to give up, but to move on? How would you advise somebody in that situation?
Yes, so I love academia, but I was at age 58, and can you imagine, I felt I am most successful in my life because I get 2 job offers. One from Moderna and other is BioNTech. At that time, nobody knew all these companies. And I get 2 jobs. The old ladies wanted. I felt so happy.
Finally, yeah.
Finally.
Success.
And so that I went, to the industry. I thought that, many good experiments, good results. And then I was wondering how it will get to the patient. And I thought that maybe I have to take it there. And so that in BioNTech, I could feel, okay, what is important? Not that getting another paper and the references or whatnot, collecting those, but rather we have to create something which will help the people. Otherwise, we can go home. Mm. And so the goal was so more reasonable, and everybody worked together. There was no competition. That everybody. And who cares? Nobody's name is important anymore. The ego is out of and that's because I find that the ego of the people is what is very difficult and slowing down many things. So there, we just have to work everybody together, share all of the information, and we work together and create a product. And that was, so that can be, go to the industry, small company, then you feel more, that every day you can work and survive that company, survival, and you can create your own company. You need $300, and you can register, and then if you have great idea, try to learn how to attract money and work on it.
What's the future of mRNA research and technology?
Endless, actually, because you can see all of these vaccines, development against viruses that we don't have any vaccines. Some of them we have, like shingles, but, that HIV, others, monkeypox is also human development. And against bacteria, like tuberculosis.
Will there be a vaccine for the common cold? Do you believe that will come from mRNA or something similar?
Yeah, It will, and they are testing out right now is more than 250 human clinical trial ongoing with messenger RNA and cancer vaccines and antibody coding mRNA and gene therapy.
As we sort of wind down, I want to take us back to January of 2020. I was at a Shabbat dinner here in San Diego, and had been invited to go to visit an observatory that does the same sort of cosmological observations that I do. This one happened to be located in Tibet, and they asked me to come and visit around March, April of 2020. And I was at a Shabbat, like I said, with some friends, and one of my older friends, Mitch, he told me, he said, "Have you ever been to China?" I said, "No, but I got this invitation." And he's like, "Well, you might want to delay it a little bit because there's this thing called, SARS-CoV-2 and there've been some fatalities even." And he knew about it on January 10th, 2020. The world didn't really, shut down until 2 or 3 months later. And when it shut down, it was horrible. The lockdowns were awful. The wait for potential vaccine, it seemed impossible. I remember saying, we don't even have a vaccine for the common cold. How are we going to vaccinate? And the vaccines weren't deployed until, late November or mid-November of 2020. And then I didn't get it until 2021 even. And even you got it around Christmas of 2020. I mean, it was, and you were probably, you could have made some in the lab and and hooked Bella up as well. But the question I have is, what went wrong? Because obviously, as awful as it is to think about, there will be another pandemic. It's inevitable. We live on a planet of viruses, as it's been called. What should be done? Let's not go back and try to litigate. As you say, you can't change the past. You're very stoic. I love that. What can we do in the future when, God forbid, but probably it is going to happen? What should governments do differently? And what role will science play in it?
We have to educate the public about, science. And, they are able to learn, they say PCR, they said mRNA, they knew that what kind of vaccine they got. And so that they can learn, and we just have to rely, and then we have to educate them. And that's what we are doing today, and the other podcasters are doing similarly, educate, because the information gap is huge between what scientists can do and where the average person knowledge on molecular biology, let's say, is. And so I believe that genuinely some people would like to know how it is all of this, what is this mRNA is doing. And of course, there are always people who knew everything better, who learned the molecular biology on internet, and they say very confidently things which is absolutely not true. And so that's what I am. Whenever I get an award or something, I get invitation. I go and have educate the public.
That's wonderful. We can do. Here we have something that I've never been awarded, but it says it has your name on it. It says the Nobel Prize in Physiology or Medicine 2023. And it's the Nobel Prize. So on the back are these two figures, and it has the date, and it has Excelsius per artis. So it has these two figures. I love it. These two women, and one is the muse of science, right?
One is sick,
okay.
helping. The other is helping with the water. There.
So we'll get a zoom in on it when we release it. So what Alfred Nobel said in his will was that the prizes had to go to those that made extraordinary contributions in physics, chemistry, physiology or medicine, literature, and peace. And it had to be not only these discoveries, the X-ray machine, quantum mechanics, et cetera, but it had to be for the betterment of mankind. Mm-hmm. And that's what is known sometimes as an ethical will. He had no children, no wife, despite the rumors, and he gave most of his wealth to the Nobel Prize Foundation that bears his name. And part of his mission was to encourage people to improve humanity, and that was his will to humanity. So I want to ask you, what do you wish to communicate to future generations of your heirs, your biological heirs, your ideological heirs? What sort of wisdom, ethical wisdom, would you like to leave them with in the future?
I emphasize always the honesty that, which I have in my life, and so the curiosity and the honesty, and you have to, what I feel that you have to enjoy what you are doing, because that's what's taking, all your life you are actually working, and feeling that what you are doing is helping somebody is just unbelievable award. I have to say that none of these awards and many other what I received had the same feeling when I read about, those who survived and because of the vaccine and they didn't die, the elderly home, they send me a letter, and I don't have to recognize. That's what the other thing. I never crave recognition. I was happy to know that, okay, I know that I did contribute it, because I have to say that thousands of people worked on this vaccine and to make sure that it will reach the people. And all of those people, the physicians, who went there risking their life, taking care of the patient, and all of the volunteers, who went there and received the vaccine. So everybody contributed, and that's how I feel. I was one of those. And I feel that I am not really different. I am one of those scientists. It just happened, so many twists and turns in my life that now I in the spotlight, which I never wanted to be. And I was very happy, 40 years, I never get any award. I don't say that if I get a grant, at least I have students and I can help them, but I am okay with it, and so I am really the same little curious girl inside me that who want to know this and want to know. And how many times in my life I said I wish I would be months older, 2 months older, because by that time we know the result.
The next question I like to ask all my guests, is relates to a famous statement by Arthur C. Clarke, who's a futurist and author, scientist, science fiction writer. And he said the following. He said, when an older but distinguished scientist says something is possible, she or he is very much likely to be right. But when she or he says something is impossible, they're probably wrong. I want to ask you, what have you been wrong about? What have you changed your mind about, if anything?
I just mentioned that I never say anybody to that when they send me their ideas that it is impossible or it is wrong. I just say that I don't have enough information. And so that's what, seeing data, and then I can have formed opinion about things. But many things are there, which I think it is possible. We just have to work more. And I don't know what I would say in our field that I would say impossible. I am very cautious about that, because I heard so many times, that you cannot do it. And, I just didn't know that we cannot do it. And I did, things like that.
And that very much relates to the title of the podcast, which is Into the Impossible, which comes from the phrase that the only way to determine the limits of the possible is to go beyond them into the impossible. And I just want to thank you so much for spending so much of your time, and you're welcome here any and all times that you come to San Diego. And thank you for these books. They're truly unique. This biography, I recommend it to anyone who's a scientist, aspiring to be a scientist. This is what it's really like. It's not all the glory, and very few people, maybe 200 people have won the Nobel Prize in medicine and the history of the planet. And so you're likely not going to win it. People aren't going to, but that's okay, because that's not what being a scientist is about. And I just want to thank you for the honesty, the humility, and really the inspiration. It was clarifying to me what, you're the first winner of the medicine prize to come on the podcast. And to me, it's such a foreign world. I always say I'm a doctor, but I'm not a real doctor. I'm not going out there. And well, Drew was doing more of it, than I could ever do. And certainly what you've done is so remarkable. So I want to thank you so much for coming here to UC San Diego, and I wish you best of luck in your future endeavors, and promise to host you anytime you have a book, which I hope it will be another book, because this one was such a delight. Katalin Karikó, thank you so much for coming on Into the Impossible.
Thank you very much for inviting me.
Thanks for watching this conversation with Katalin Karikó. I know you'll enjoy this conversation that I did with Eric Topol, and for a slightly different perspective, please see my interview with Jay Bhattacharya. And click here for a playlist of the best episodes from recent weeks in the Into the Impossible podcast.